So this is one of the examples of solving some basic circuit law. So for our first problem, we're looking for VO and VI, assuming that this is our VA and this is our VB. By applying Ohm's law, so we're using KCL at node VA. So VA over 4 plus VA minus VB over 10 plus VA over 6 plus VA over 12 is equals to 0. Combining like terms, VA over 4 plus VA over 10 minus VB over 10 plus VA over 6 plus VA over 12 is equals to 0. So 1 over 4 plus 1 over 10 plus 1 over 6 plus 1 over 12 VA minus 1 over 10 VB equals to 0. So 3 over 5 VA minus 1 over 10 VB equals to 0. So this is our equation number 1. So applying the same process by Ohm's law, KCL at node B. So VB over 4 plus VB minus VA over 10 plus 20 is equals to 0. So the same process, combining like terms, VB over 4 plus VB over 10 minus VA over 10 is equals to negative 20. So 1/4 plus 110 VB minus VA over 10 is equals to negative 20. So 7 over 20 VB minus V over 10 VA is equals to negative 20. So negative V10 VA plus 7 over 20 VB equals to negative 20. That is our equation number 2. So by using calculator, mode 5 1, so we input the first equation that we have at VA. So 3 over 5 minus 1 over 10 0. So after applying the equation 1, we apply the equation 2. Negative 1 over 10 plus 7 over 20 negative 20 equals, so our VA is equals to negative 10 and our VB is equals to negative 60 volts. So since VO is equals to VB, so VO is equals to negative 60 and V1 is equals to negative 10 volts. So that's problem number 2. If the power supplied by the 3 ampere current source is 12 watts, find Vs and the power supplied by the 10 volt source. So this is our circuit. So for our first step, KVL at loop 2. So assuming that this is our loop 2 here, so negative V6 plus V4 plus V5 is equals to 0. So V6 is equals to V4 plus V5. So 8 volts plus 10 volts is equals to V6 is equals to 18 volts. So our V6 is 18 volts. So KCL at node A, assuming that this is our node A, is our node here. So by applying Ohm's law again, I3 is equals to I6 plus I4 plus 3. So using the Ohm's law, I3 is equals to V6 over 6 plus V4 over 4 plus 3. So I3 is equals to 18 over 6 plus 8 over 4 plus 3. So our I3 here is 8 volts. So for solving the V1, V is equals to I times R. So 3 amps times 4 ohms. So our V1 is 12 volts. So KVL at loop 1. So negative V4 minus VA plus V1 is equals to 0. So V4 is equals to V1 minus VA. V4 is 12 volts minus 4 volts. So our V4 here is 8 volts. So for solving V3, I3 is equals to 3. So V3 is equals to 8 times 3. So our V3 is 24 volts. So KVL at loop 3. Since we're looking for Vs, so now we can solve our Vs by using the equation loop 1 after solving loop 1, loop 2, and node A. So negative Vs plus V3 plus V6 is equals to 0. So Vs is equals to V3 plus V6. So Vs is equals to 24 volts plus 18 volts. So our Vs is 42 volts. After we found out that our Vs is 44 volts, we can now solve for power supply. So for power, P is equals to ampere times volts. So P10, because power supplied by 10 volts given at the question. So P10 is equals to I10 times 10 volts. So negative 3A times 10 volts. So by using calculator, our final answer is 30 watts. So our power supply in this circuit, for the whole circuit, is 30 watts. 30 watts, and the Vs is 42 volts. So for problem number 3, we are looking for I1. So this is our circuit. For us to solve the I1, we will apply delta to Y. So we will draw the circuit. So this is our R1, and this is R2 and R3, RA, RB, and RC. So our RA is 18 ohms, our RB is 18 ohms, and our RC is 18 ohms. So for solving R1, we will just use the series. So RB times RC over RA plus RB plus RC. So 18 times 18 over 18 plus 18 plus 18. So our R1 is equals to 6 ohms. So we can just use the same process for the R2 and R3, because all of them have the same ohms. So we can just repeat the steps so that we can arrive to 6 ohms. So our R2 is still 6 ohms, and an R3 is still 6 ohms. So after getting the 3 ohms rather, we will redraw our circuit. So this is our 18 ohms, and the I3 is flowing here. So node, so 12 ohms, (3 ampere), 6 ohms, and our source 3A. We have our I1 here. So after we redraw our circuit by getting the R1, R2, and R3, we will just apply the current division. So applying current division is equals to I1 equals negative I3. So negative 3 over 12. Negative I3 times 12 over 12 plus 18 rather. So this is our solution. This is our equation by applying current division. So by using calculator, we will arrive to negative 1.2 ampere. So this is the I1 that we are looking for this circuit. So the I1 here is negative 1.2 ampere. So for our last example, the power absorbed by the box is PT is equals to 2.5 E raised to negative 40 watts. Compute the energy and the charge delivered to the box in time interval 0t to 50 milliseconds. So sorry for the shaking. So this is my circuit, or our circuit rather. So this is the box that the question is referring to. So we are looking for energy and charge here. So first we will look for the energy. So for the formula of energy, so this is the formula of energy. We will apply definite equation here, or if you're familiar to your integral subject, you can apply it here. So integrate 0 to 50 milliseconds to 2.5 e raised to negative 40 dt. So we will just put the 2.5 here. So integrate 0 to 0.25 e raised to 40. So 2.5 times e raised to negative 40 over negative 4. Integrate 0.25 and 0. So for watts, 2.5 e raised to negative 4 times 0.25 over negative 4 minus e raised to negative 4 times 0 over 4. So 2.5 times 0.092 plus 0.25. So 2.5 times 0.158. So by using the calculator, we will arrive to 395 millijoules energy. So this is our energy here. After we solve for our energy, we will look for the charge of the problem, or the circuit rather. So for the formula of charge, I is equals to P over V. So 2.5 E raised to 40 over 50 E negative raised to negative T. So 2.5 over 50 E raised to negative 40 plus T. So 50 E raised to negative 3T and A. So charge is equals to T. We will still apply the definite equation. So T1, T2, I, T, dt. So 0.25 raised to 0, 50e raised to negative 3t dt. So we will just apply the same process. So 0.05 integrate to 0, 0.25 e raised to negative 3t. So 0.05, 0.25 times e raised to 3t over 3. So 0.05 times e raised to negative 3, 0.25 over negative 3 minus 0.05 e raised to negative 30 over negative 3. So by using the calculator, we will arrive to this answer. So negative 0.00787 plus 0.0166. So by using the calculator, our charge is 8.8. So after we come up to this answer, so this is the charge of the circuit. This is the energy of our circuit.
So that's it for my video guys. Hope you learned something and hope you understand how to solve some basic circuit laws. So thanks for watching.